Namaskar dosto, welcome you all in this new video, and in this video we are going to discuss a very interesting topic, okay, and we are going to derive the expression for binding energy of the electron by using what Heisenberg uncertainty principle, okay. And this is very important principle. We mainly studied about it in the quantum mechanics, okay. Quantum mechanics means that part of physics which deals with the atomic level things, subatomic level things, okay, all these things, and whatever the phenomena occur in atomic level, means in Fermi level 10 raised to power minus 5 meter or something, okay, that is known as quantum mechanics, and all the phenomena which occurs there, okay, we studied by quantum mechanics, okay. So in this video, what we are going to do, we are using Heisenberg uncertainty principle, okay. We are using this principle, okay. For what? By using this principle we will derive the expression for binding energy of the electron, okay, binding energy of the electron, okay. So what is this Heisenberg uncertainty principle? Okay, it says that when a particle is motion, okay, when a particle is in motion and we cannot measure the position and momentum of that particle simultaneously, okay, if we are measuring the position of that particle very accurately but we cannot measure simultaneously the momentum of that particle with absolute accuracy, as you are measuring with accuracy, you are measuring position, means you cannot measure these two, position and momentum of a particle when it is motion, when it is in motion, okay, simultaneously. Means what? That this is your particle, okay, this is moving there, and at a particular point you are indicating this particle position, okay, it means that you are measuring the position of this particle, but at this time you cannot measure the momentum of this particle, okay. So it means that momentum and position cannot be measured simultaneously, okay. So we can write it through the mathematical indication, that is delta x. This is for uncertainty in the position, means we don't know about the position, okay, accurate position, so we are taking this uncertainty in the position, and this is the product with what? Uncertainty in the momentum is greater than or equal to h over 2 pi. So this is the mathematical indication for Heisenberg uncertainty principle, okay, and we will replace this thing by h dash. So overall mathematical indication that we get, okay, that is delta x dot delta p, means the product of uncertainty in the position and uncertainty in momentum is what? Is greater than or equal to h dash. By using this expression we will derive the binding energy of electron, okay, binding energy of electron. What is this binding energy? Binding energy means the energy with which that electron is bound with the nucleus, okay. You know that this is your atom, okay. Here we are going to derive the expression for binding energy, okay, of the electron that is revolving around the nucleus. Like this is your nucleus, okay, and electron is here revolving, okay, at a distance of r. Let this O is the nucleus and r is the distance of that circular path or that orbit in which the electron is revolving, okay. So what we are going to consider? We are consider electron, okay, moving with velocity, let velocity is v, okay, in an orbit of radius r, okay. What happened? Electron is revolving around the nucleus, this is the nucleus, and in a orbit of radius r, okay. So what happened now? By using uncertainty principle, okay. Now see what is this uncertainty principle and what is the mathematical expression that we had derived for this principle, okay. That was delta x dot delta p, okay, is greater than equal to h dash. Now see what is this delta x? Delta x means uncertainty in the momentum, okay, sorry, uncertainty in the position. uncertainty in position means where is the probability to find the position of that particle, okay, where that particle can be find, okay. So by looking at this diagram, we can say that the electron is within the range of the radius of this circle or this orbit, okay. It means that uncertainty of electron will be equal to or similarly equal to the r means distance between nucleus and electron, and in this region we can find the electron anywhere. So here we are not absolutely correct where is that the position of electron, okay. So we are just assuming that uncertainty in the position is r is the radius of electron orbit, okay, in which that electron is revolving, okay. From this expression we get delta p is greater than or equal to h over what, delta x, and this is equal to h dash over r, okay. So this is the uncertainty in momentum, okay. Now considering that momentum is the minimum momentum, okay, this minimum momentum what will be p, okay, that is what, p is equal to delta p, and delta p is greater than or equal to h naught over r. So p will be equal to h naught over r. So this is the p expression, okay. Now see the what will we now derive? We have to derive the binding energy of the electron, means what, this is your electron, okay, revolving here. So we have to derive the expression for this energy, okay, with which that electron is bound with the nucleus, okay. So what is this, we know that total energy means what, total energy means kinetic energy plus potential energy, okay. And if we want to calculate the minimum energy, so we have to do this thing, dE over dr equal to 0. This gives the expression for minimum energy, okay. So look at here, what is the total energy? Total energy is E, that is equal to kinetic energy plus potential energy, okay. What is the kinetic energy? Kinetic energy means p square over 2m. What is this m? M is the mass of the electron, okay. So p is what, p is equal to, that we get h over r, okay. So now place the value of p in this expression, so we will get h dash square over 2m r square, okay. So what is the potential energy? Potential energy, you know that minus z e square over 4 pi epsilon naught, okay. What is this z? This z represent your atomic number, whatever you will say. For hydrogen this is 1, okay. Now this is the over r, this is the potential energy. And what is the kinetic energy? This is the potential energy, and kinetic energy you are going to add this, okay, h dash square 2m r square, okay. So this is the total energy expression. So total energy is what, h dash square 2m r square minus z e square over 4 pi epsilon naught r, okay. Now you are going to differentiate this E to get the minimum energy, okay. Means the energy will minimum when dE over dr is equal to 0, okay. By differentiating the E, okay, I am writing directly here, minus h dash square over m naught r cube, okay, plus z e square over 4 pi epsilon naught r square is equal to 0, okay. From here I am getting the value of r. R is the radius of that orbit, okay, that is r equal to 4 pi epsilon naught, okay, h square over m naught z e square. So this is the expression for r. R means the radius of that orbit, okay. So now putting the value of this r in this expression, okay, that we have getting, what was that expression? Kinetic energy plus potential energy, okay. What was your kinetic energy? H dash square over 2 m naught r square minus z e square 4 pi epsilon naught r. Okay, so this is the expression for total energy. Now we had get the value of r. What is the value of r? That was 4 pi epsilon naught, okay, h dash square over m naught z e square. So this is the value of radius of radius of orbit. Now replace the value of r, okay, from this expression. You will get the final expression for this energy, okay, that is E. E means what? This is the total energy or binding energy of the electron, okay. You will get the value of total energy or binding energy of the electron by replacing the value of R from this expression, okay. So this is all about the binding energy of the electron by Heisenberg uncertainty principle. I hope you like this video, and if you like our video then give a thumbs up to us, okay. Thank you so much.